So this time we are finding effective value, right? Effective value or RMS value or root mean square value. If you see any of this, is the same thing, right? So the procedure is similar, but then slight differences. So we're going to go through it, right? The first one says identify the cycle. We've done that already. We could say that is this, and this, right? We've done that. And then it says find the period of the cycle. We've done that. We know it ends here, so that's from here to here. That gives us 4 seconds, right? 4 seconds. Okay. So if we're to be the average value, we have introduced, we have gone straight to this. But then for the RMS value, it says there's something here. It says square the cycle. Okay, so we're going to go through that value. Square the cycle, right? Meaning that whatever the cycle that you have there, you just square it, right? So looking at this one very well, let's go to the squaring. If you think of the squaring, it's basically like squaring the area, but let's go through it. So this one like this, if we square it, so let's see, the cycle from here, let's see, here, here, and here, right? Okay. So if you add squaring this, it means that here becomes e squared. So it actually becomes about twice, right? So let's make it that way, so that's clearer. That's how I go today. It becomes about twice of its initial, right? When they get, okay, a minute. There's the first part, right? It's squared, right? So here, all this side becomes e squared. So we square the first part of the cycle. The next part is this, right? But then, so let's look at it. The time won't change, but just the value on the y-axis that change, right? So we square this becomes e squared, right? And here as well, you see here we have negative e. When you square negative e, right? When you square this, it gives us just e squared, right? So it means that this whole area here comes up squared but positive, right? So it ends up being something like this. Another, let's see. So mostly similar to like just squaring the area, right? So this is the first cycle. The one in brown here is the first part of the cycle squared, and the one in red is the second part of the cycle squared, right? So everything moves up. So everything has moved up like this, right? So now it shows that our area of interest is the area under this, right? This side or here, right? Okay. So now we've done this. We found the cycle, identify the cycle of the waveform. We found the period of the cycle of the waveform. Now we square the cycle, right? The next will be this will be 4, right? 4. Next will be to find the area under the squared. So under the squared, right? The area under the squared cycle. Okay. The area under the squared cycle. So that's what we're going to do next. So we know that the area for the first part of the cycle is this. So let's see. So this one here, right? So that'll give us e squared, right? Because it's a rectangle or something, right? So that's e squared times the base, and that gives us 2. Sorry, times 2. Yeah, so that gives us 2e squared, right? And then for this side, let's bring it here. Let's see. So this is for the first part. So the first part, now the second part to be this. We get, we still have e squared, right? And now what do we have? We're multiplying it by 4, right? 4 here, minus 2, right? And then again gives us 2e squared, right? Okay. So when we add up the areas, the area under the cycle, so total area under the cycle, total area, not just under the cycle, under the squared cycle, right? Total area of the squared. Squared is very important for the RMS squared. RMS squared for the squared cycle, right? and that'll give us 2 e squared, right, plus 2 e squared, right, and what does that gives us 4 e squared. So 4 e squared, right, let's remember the squared area, right, the area of the squared cycle, right, squared cycle, very important, because if you miss this, everything will be lost, right. So okay, let's see, squared area. So now that we've found the squared area, what's the next thing? The next one will be, so we've done this, found the area. Now we divide the area, right, the squared area, let's put it there, the squared area, divide the squared area or the squared cycle, yeah, the squared area by the period, right. So now we know the period is 4s, right, so and then we have 4. So basically if we divide that, that will give us what we call average, right. So not average like average value, just average. In fact, the better term for that one is mean. Yeah, mean value. Yeah, mean value. Okay, so the mean value will be this 4 e squared that we found, all on the period, which is 4, right, and that gives us e squared, right, where e could be a value, right. So that's not just a symbol or something, e could be a value. So we have this. The next thing to do will be to, let's see, that will be the, so this right here is the 5th step. We're just trying to relate this one to the average value procedure, right. So the 6th step will be to find the square root, square root of the mean value, right. A minute. Square root of the mean value. So it's very important that you know the average, the procedure for the finding the average, and then you know the procedure for finding the effective or the RMS or the root mean square value, right. So now the last step of the finding the RMS will be to find the root of, right, the root of the mean value. The mean value is, which we've said to be the squared area divided by the period, right. Okay, yeah, so there's the last step of it. So you do that. So that will mean that the RMS for this particular cycle will be the square root of this e squared that we have, right, and that will end up giving us e, right. So if it happens that the graph were to be in volt, like were to be in this one, the time is a voltage plotted against time in RMS, that will be e, which could be any value, volt, right. So if it were to be current that you see on the graph, so let's say if it happened that there was no volt but just current, right, on that's the y-axis of the graph, and then the IRMS will give us E or whatever that is there, amperes, right. Yeah, so that's it for this particular example. Yeah, okay, all right.